to Neo the Nomad YouTube channel. This video is regarding WA2EBY. This is a push-pull linear RF amplifier which I was using for my Bitex, and one fine day I just overpowered it using my 12 volts or variable power supply. Instead of giving 12 volts, I think I gave around 30 volts or something, and this has gone bad. So this video is regarding the troubleshooting and to repair what uh, to see what can be done in order to repair it. In order to test my linear amplifier, I'm using my Bitex. Hope you remember this particular Bitex, where I have a series of Bitex construction videos, and this is the same Bitex, and I'm using an SWR meter and power meter, and this is the linear which I've connected, and the connection to the linear, this is how it is connected from the Bitex. It is directly going to the input of the linear. From the input of the linear, it actually amplifies and comes to the output. This is the output of the linear push-pull amplifier, and from the output I am feeding this to this particular SWR power meter, and from the power meter, as of now, I'm only using the dummy load over here. That's the 50 ohms dummy load. So ideally, I am pushing around 2 watts from the Bitex. From the Bitex, I am pushing 2 watts, and since this particular linear is on, and also both the power supply, they are on, and I should get some more than around 20 watts. But let me see how much I'm getting. All. So I'm just getting around 1 watt. So even if I switch this off, switch the linear off, and if I use it all testing, so I'm getting the same output. So looks like this linear is not getting the amplification. So the amplification is gone bad, and I need to do the troubleshooting now, and hopefully I should be able to fix it. Let's see what happens. This is actually a COR circuit, that is carrier operated relay circuit, which was being used in the amplifier. This I was using earlier, and what I did, I suspected that this particular circuit and relay has gone bad. So I disconnected this particular circuit, and I had got a ready-made carrier operated relay. So this is the ready-made carrier operated relay board which I got from one of my friend. So I also tried checking this. So the inference is it's not actually the problem of this particular COR circuit. Looks like the problem is elsewhere, and now I need to check the way the problem is. Let's visually inspect if we have any blown components, and as I see in the first run, I don't see any blown components over here. I don't see any charred or blackened components, and the section wise, if I have to just give a brief introduction, this is actually the input section of the amplifier, and this is the input transformer, and this is the biasing circuit for the MOSFET. These two are the MOSFET, and we use IRF 510 is the MOSFET that we are using. And after the amplification, the RF amplified signal goes through the output transformer. From the output transformer, it gets converted to the RF output, and it takes here. So what I see here, as I do not see any visual signs of components going bad, first what I'll do is I'll just try to check the IRF 510, that is the main MOSFETs using a digital multimeter. And also I'll try to do an inference with, I also have another a working RF amplifier. I'll also check with that so that I'll get to know if there are any difference. What we'll do is we will check the MOSFET IRF 510 using a digital multimeter. So I'm using a digital multimeter. It is from the company Vartech. This is a very popular digital multimeter over here in India. And I'm sure you would have seen a lot of YouTube videos on to how to check the MOSFETs using a digital multimeter. Probably this would be a duplicate, but nevertheless, I will teach you quickly how to check the MOSFET using the digital multimeter. So we will set the setting for the continuity mode. This is the continuity mode, and you'll get the beeper, and if there is continuity. And also you can select the diode mode as well. If you select the diode mode, you'll just get the reading. You might not get the beep sound over there. So I'll select it to continuity mode for checking the MOSFET. So as you know, the IRF 510 is an N-channel or N-type MOSFET, N-channel MOSFET. You have the terminals as gate, drain, and source. That is, I remember it as GDS, gate, drain, and source. So as a MOSFET will always act as a switch if there is a voltage across. So what we plan to do, or how the way how I test is, first I'll try to check the continuity between the drain and the gate. So the drain is the center pin, which also connected to this tab, and when you keep the negative on the drain and see the continuity over here, there should be a continuity, there should be a connection. But however, if you check the otherwise, if you keep the positive at the drain and check for the source, there should not be any conduction. The conduction should not be there. So because from drain to source, it acts as a diode, so it is only one way. So in order to charge the MOSFET and to check if there is a conduction from drain to source, we need to actually activate. It is called as switching on. So we need to keep the positive at the source, and at the gate, we have to keep the positive at the gate and the negative at the source. The MOSFET will be switched on. So once when it is switched on, and when you see the continuity, you can hear the beep. It is actually on. So in order to switch it off, just short the drain and the source. If you short the drain and the source, it should go. Now there won't be any continuity. I'll just reshort it again. See, if I reshort it, and then it will there won't be any conduction. So that's how you can check the MOSFET. Now I have checked both these MOSFETs in the similar way, and both these MOSFETs are working absolutely fine. No problem with these two MOSFETs. Now what we'll do is I'll try to check the MOSFETs on this particular linear and check if how will that behave. Now in order to test the MOSFET, again I'll keep the negative on the drain on the first MOSFET, and I will keep the positive on the source. So as it is on the board, although I am not getting a beep, but I'm able to see some readings on my digital multimeter. All right. So I will also check the second MOSFET in the same way. Even it is showing a reading of 557. All right, so now I will reverse the polarity. Now I'll keep the positive on the drain for the first MOSFET and negative on the source. Okay, so I got momentarily a beep and a reading and it went off. So again, I'll see on the second MOSFET. Second MOSFET also same. I see momentarily some reading and it just went off. Okay, now I'll just try to short the drain and source so that ideally it should not give have any conductivity, but I see it's conducting. Even this, it is conducting. So since it is conducting on the reverse as well, there's no point in switching on the diode and seeing that. But let me also check if I'll switch it on and check if there is any continuous conduction. So I'll put the positive on the gate and the negative on the source and switch the MOSFET on. Now I'll check if there is any. Okay, so it is same in the same way. It just conducts and it just goes off. All right, so as the MOSFET, they are on the circuit and on the board itself. So maybe what I need to do is I need to desolder them, take that out, and probably I need to check the MOSFET in the same way, I suppose. Now I have dismantled the IRF 510 MOSFET from the circuit, and now we'll try to check the MOSFET using the digital multimeter in the same way. Now we'll test in the same way. I have kept the digital multimeter in the diode position. I'll keep the negative on the drain and check the continuity on source. So there we have a continuity for the source, and now I'll try to change the polarity, positive on the drain and negative on the source. Okay, so now we do not have. So if you remember earlier when this was mounted on the circuit, we used to get a momentary continuity and it used to go off. So now from on the gate, if we put on the drain if we put the positive, and on the source we put the negative, we do not have. So what I'll do is I'll switch it on, momentarily switch on the MOSFET, and I'll check. Okay, now we have the MOSFET is switched on and we have the continuity for drain and source. So I'll just short it and now I'll check. Okay, so it is switched off now. Looks like the MOSFET is working, absolutely working fine over here. So I'll end this particular part one of the video. If any of my subscribers have any answers for this or any comments as to how I need to check next, what is the next thing I need to troubleshoot, please do comment in the comment section. Hope I should be able to rectify this amplifier, and I'll see you in the next video.